Hello, in this video we're going to continue working with the Office dataset and try to get more practice building models, feature engineering, doing cross-validation and prediction. So I'm going to go ahead and start the 9th application exercise called the Office. Okay, so let's go ahead and open up our Markdown document called the Office. And I'm going to knit this, but before I do that, I want to do a couple things. I want to see chunk output in console, and I want preview and viewer pane. So both of those are checked. So let's go ahead and give this a knit. Okay, so we have data from the Office, and this time we're not going to use the data that we used in the previous video that came from data.world or Tidy Tuesday, but instead we're going to use the data from a package called Shroot. So that's Dwight Schrute's last name, Shroot. So we can take a look to see what's in this package. We have a nice BTEX logo, and basically it says that there is a data set called the Office. And it has 55,000 something observations and 12 variables. And in this data set, we have season, an episode name, director, writer, character, and then we actually have the words spoken by the actor. So we actually have text data here, and we're going to work with a little bit of this text data in this example, but we also have the other data we worked with previously called IMDB rating, total number of votes, and then the air date. So let's go ahead and load the packages that we have. So that's Tidyverse and Tidy Models, Shroot for the data set, and Lubridate. We're going to do one date manipulation, so I've added that here as well. We can take a glimpse at our data. We can see the number of rows and the columns here, and we can see something like, okay, the first person who spoke is Michael, and then it's starting with something like, all right, Jim, so on and so forth. Okay. So one thing we want to do before we get started is that as I was playing around with the data set in this package, I realized that air date was coded as a factor variable. Maybe makes sense. We have a lot of repeated data in the air date column because remember we have a row per each line spoken. So for a given episode, we're going to have a lot of that sort of episode metadata repeated. But we're going to convert that to a date object because we're going to ultimately in this application exercise compare what we're doing to the results we had. All right, go ahead, Dorian. The results we had in the previous video where we had extracted out the month of air date. So I want to just save this as a date variable so it looks just like what we worked with before. And so I have the Office is the name of the data set that we're working with, and I've overwritten it to specify date as a air date as a date variable. And if we do a glimpse again one more time, we can see that we were able to successfully change its type. Okay. So let's see, it says, engineer features based on episode scripts, train a model, perform cross-validation, and make predictions. So one quick note, the episodes listed in this data set don't match the ones listed in the data we used in the previous video. They match, majority of the time, but there are a few differences. In fact, if I take a look at this data set and then take a look at the combination of distinct seasons and episodes, I end up with 186 rows as opposed to 188 rows that was in the previous data set we had. And I tried to do a little bit of digging around, and the difference seems to be due to a couple times there were double episodes that aired, like a part 1 and part 2. And this data set I think considers them as a single episode because they aired on the same date, and then the previous data set we looked at actually considered them as separate episodes. I think that if we really wanted to do an apples and apples comparison to the numbers we got in the previous video, then we would want to make sure that these things match. But for now, we're just going to let that go. I'm noting that in case you are curious as to why there's a mismatch, but we're just going to let it go for the time being and work with these 186 episodes as outlined in this data set. So for our first exercise, what we're asked to do is to calculate the percentage of lines spoken by Jim, Pam, Michael, and Dwight for each episode of The Office. I'm not an Office expert, but I think they are considered the main characters. I think that's who I think of when I think about the main characters. And personally, for me, those are the ones that I enjoy listening more than some of the other characters. Not a big fan of Andy. He sings a lot. I don't really like it. So I decided, I wonder if we're going to see, if there is a conversation between, or if one of these characters speaking more might be associated with higher scores or not. So how might we go about doing this? Remember, we have data on each of the lines, so I can actually count up how many lines are in a particular episode and then figure out what percent of those are spoken by each of the characters that we have listed here. All right, so in that case, what we might want to do is say The Office is the data frame that we're working with. We want to do some calculation at the episode level, but when we say episode, really what we mean is we group by season and then episode, because there's episode 1 in multiple seasons, for example, so we want those combinations. And one of the things that we might do is say, let's calculate the number of lines in each of the episodes. So I'm going to call that variable n lines, and I might just do this function n to say this is the number of lines in each of the episodes. So let's go ahead and run this. I can see the result here, but it's a little bit hard to see what those numbers are since the table gets truncated. So I'm going to use the relocate function to relocate these new variables, at least temporarily, as I create them. So we can see, for example, that in episode 1, we had 229 lines, for example. Another thing I might want to do is to do a quick view, so I can open this up in my data viewer, which might take a little bit of time because it's a big data set, but I am going to, scroll down just a little bit to the next episode just to confirm that, yeah, so for the second episode, I have a different number for n lines, but it's also in the right ballpark. These, episodes roughly take the same amount of time, so each week, so we would expect roughly similar number of lines. So I know that now I can count the lines. So now what I need to do is see how many times Jim spoke or Michael spoke or something like that. So if I take a look at the data, I can see that who is speaking for any given row is listed under the character variable. So I might say for each one of these episodes, I want to count how many times, let's start with Jim. Jim occurs, okay? My data is already grouped by season and episode. So if I wanted to do something like, let's call this lines Jim, we could say, take a look at the character variable. And really, I want a true statement if character is equal to Jim, and then I want to sum these up, okay? So this would be the number of times that Jim spoke in a particular episode. So let's go ahead and do this. Relocate that new variable as well. And let me go ahead and try one more. So that's lines Jim, and I will do lines Pam as well. So let's go ahead and run this. It's character. Try that again. All right, so we can see, for example, and if I bring this to the front as well so I can see it a bit more easily, we can see, for example, that in the first episode that was 229 lines, Jim spoke for 36 lines and Pam spoke for 41 lines. Okay, but what we wanted was the percentage of lines spoken by them, or the proportion of lines. So really what we want to do is divide these numbers by n lines. Lines Jim. Okay, and let's do this for, we have Michael and Dwight as well. Actually, it's not right. I want to divide everything by the number of lines. So I want to calculate how many times somebody spoke and then divide it by the number of lines. So for example, for Jim, I had 36 out of 229. So that is 15.7%. So let's go ahead and run this, and maybe we can bring up. So if it contains the word lines in it, let's bring that up. And we can see, in fact, that for Jim, we have 15.7. So that number we manually calculated matched, which makes me feel confident that I may not be making a terrible mistake here. Okay, so we actually have this information. One thing we can see is that our data is still grouped by season and episode. So what I'm going to do is I am going to, so I can actually get rid of this relocate at this point. I'm happy with what it is. I don't need these data at the very beginning anymore. So I'm going to ungroup my data, first of all. So that gives me an ungrouped data frame, same number of rows, but I have these additional columns that I just created. And then really what I want to do is I want to just store this data at the episode level. So right now we have a lot of repeated information for each of the lines, but I want to actually store it at the episode level. So for that I can say, let's do, I want to, maybe as an identifier, I want maybe episode name. Or maybe season, episode, oops, an episode name, and then anything that contains this lines underscore. So I don't really need the length of the episode, the end lines. I just want the ones that go lines and then underscore. I want these data only. So for each of the episodes, I want these pieces of information. And then what I want to do is I want to say distinct, for these things, but then let me show you what I'm doing here. I'll get rid of this for a second. So if I do distinct, then it just gives me the distinct combinations of season, episode, and episode name, but I don't want to lose out the variables that I had calculated. So I'm going to say keep all true. So now I have for each season an episode, and I'm just keeping the episode name around because I don't know, I kind of like seeing them as we go. They're nice identifiers. And then the variables that we calculated. So what I'm going to do is I'm going to save this data set as office lines. Let's save that and let's run it. And that gives me 186 rows, which is promising, right? That's basically the number of rows that I had calculated at the beginning. So now I have this metadata information about the number of lines for each one of them. Good. I've finished an exercise. This is a good time to knit my document just to make sure that, you know, everything that I intended to do is in fact functional working code. That's looking good. So we're going to just keep checking along. Now it says identify episodes that touch on Halloween, Valentine's Day, and Christmas. How might we do this? Now, we could think about dates for doing this, but it's not necessarily true that just because an episode aired on Halloween, that it would be about Halloween. And also usually if you know about TV shows, if it's kind of like adjacent to Halloween, they might have an Halloween episode. Like if it's the same week as Halloween or Valentine's Day, they might have something related. And I don't really want to dig through for all these years what the dates were and whether something falls into the same range. So what I'm going to do is I'm going to work with the text data. And I'm actually going to just look for the existence of words like Halloween, Valentine's Day, and Christmas. So if we take a look at our data, the office, this is not the data set that we just created with the number of lines, but our raw data. We can see that we have this text information. And if I hover on one of the boxes here, it tells me exactly what it is. And we can see that those are like the lines from the episode, and they are all capitalized like sentence case, since they're coming from the script. But one of the things I want to do is I don't want to worry about whether the word Halloween was capitalized or not. So I am actually going to start by overwriting my data set and say that this text column, yep, I'm going to overwrite that to say, turn that to lowercase. And so if I now view this again, I should be able to see the same information for text, but everything is lowercase. So then when I'm matching for various words, I don't need to worry about whether something is lowercase or uppercase. So let's go ahead and start with Halloween, okay? What I'm going to do is I am going to create actually 3 separate data frames, one that has information on Halloween episodes, one that has information on Valentine's Day, and the other one on Christmas, and then we're going to combine this information. So let's start with our office data frame. And really what we're interested in is we're interested in the rows where we can detect. So I'm going to, from the stringr package, use the str detect function in the text column, the word Halloween, okay? So as a text string. So there it is. We can actually see that there are about 34 rows where Halloween was mentioned. And it looks like one of these actually is a Halloween episode because the name is Halloween. But then there's another episode called Diwali, or another episode called maybe employee training, something like that, where it seems like it's showing up multiple times. So what I'm going to say is if it, for example, here in this episode called Diwali, Halloween shows up just once, I think. Maybe let's go ahead and view this data frame to see if we can get a little bit more insight into what's happening. Here we go. Blah, 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 something. Okay, this is Michael being entirely inappropriate, as he usually is. But it does say something about Halloween in there, but it's not actually, he's trying to understand what Diwali is, and then he is equating it somehow to Halloween in the awful way that he does these things. But he, that episode is not about Halloween. So there's only one mention of Halloween, and that's just like kind of a passing comment as opposed to a real thing. So what I'm going to do is I'm actually going to, let's count the episode name. I'm working with the episode names because we don't, like, the episodes appear multiple times, or the same number episode appears in various seasons. So episode names are unique. So I'm counting these, and then I'm going to say that I actually want to just filter things for where n is greater than 1. So these are, I think, the episodes where it looks like there may be more actual mention of Halloween happening. So they may actually be Halloween related episodes. And if you look at the name Spooked Halloween Costume Contest, that probably is the case. So what we're going to do is we're going to add a new column here called Halloween, and I'm going to set that equal to 1. That's just something we're going to use later as an identifier column. And I'm actually going to then select out this N column. So basically I have this mini data frame for Halloween that has episode names and the number 1 that for Halloween. Okay, so that's something I'll be able to merge back to my data set with, and I don't really need the counts anymore of how many times things were mentioned. I already used that information and I'm done with it. So let's call this Halloween episodes. And then I can do something similar for Valentine. Maybe we'll say Valentine for this, and let's go ahead and run the same code. Oh no, this should also be Valentine, not Halloween. Couples discount, PDA, public display of affection, Valentine's Day, obviously. So I think this is possible that these were also about Valentine's Day. And then let's do it one more time for Christmas. And we're, you know, on the cusp of thinking, should we have written a function for this? But we'll let that go for now. And so these are, let's see if those might be true, Christmas episodes, lots of stuff that actually have the word Christmas in it, Night Out, Secret Santa, Benihana Christmas. Oh my God, that was an interesting episode. So, all right, I think we have the information that we want here. So we're going to keep these in our pocket for use later. Let's go to exercise 3. So now we're finally asked to put together a modeling data set that includes features you've engineered. And then we're going to add also an indicator variable called Michael, which takes the value 1 if Michael Scott, so Steve Carell, was there, and 0 if not. So if you know about the show Office, Michael Scott, so Steve Carell's character, was not there for the last 2 seasons. So he left at the show at the end of season 7. There's actually an episode called Goodbye, Michael, and then he leaves. So we're going to also add an indicator because, I don't know, maybe it's possible that once he leaves, the show is not as popular anymore. So let's go ahead and do that. So we are going to start with the Office data set, right? That's what we had. And let's select some of the variables that we want. So we definitely want season. We want episode. Name. We want the IMDB rating. We want the number of, let's take a look. We don't want the director, writer, character. Those would be interesting to look at, but we're not going to use them in this example. Total votes. I'm going to hold on to air date. And then let's take a look at, so remember the Office data frame has 1 row per line, but I want to say that I want to get distinct combinations of episode and season, and let's keep all equals true so that we actually have information kind of like the information that we started with in the previous video. 1 row per episode and then some of this metadata. But now we can actually join things. So we can do a left join with the Halloween episodes, and then we're going to do that by episode name. So we have some NAs, but let's take a look at what's happening here. I'm going to do a view real quick. And okay, so the episodes that we had identified as Halloween episodes have gotten 1s, but then the rest of them are NAs. We probably want them to be 0s, but at least things are going well for now. Let's do the same thing for Valentine episodes and Christmas episodes. And then let's do another view to make sure things are looking good. We checked the Halloween already, Valentine's. I'm just sorting these and those are looking good. So now what we want to do is all of those NAs, we want to convert them to 0s. We could do this with like a mutate and case when for each of these variables, but there's actually a really nice function in the tidyr package called replace NA. So that might be a useful one to know about. So the replace NA function basically replaces NAs with specified values. It can take a data frame or a vector. So we have a data frame, we can pipe into it. And if it's a data frame, it says replace takes a list of values with 1 value for each column that has NA values to be replaced. So 1 value for each column that has NA values to be replaced. So those are going to be the columns called Halloween, Valentine, and Christmas. So let's do that. Replace NA. And that's going to be a list, it says, of, in the Halloween column, we want the NAs to be 0. In the Valentine column, we want it to be 0. And in the Christmas column, we want it to be 0 as well. Okay, so that worked, and we can see it looks like it worked for the Halloween one. Now the next thing that we were asked to do was to create this new variable, right? A new variable called Michael. So let's create a new variable called Michael. And we'll say if else season is greater than, or let's say, yeah, if say season is greater than 7. So if it's 8 or 9, I want this to take the value 0. If it's 1 through 7, I want it to take the value 1. So that worked, but you can see that because I've given it 0 and 1 values, these are now all numeric, but really this is supposed to be an indicator variable. And so are the Halloween, Christmas, and Michael variables supposed to be indicators as well. So really what I want to do is now I want to convert the types of the variables Halloween, Christmas, Valentine, and Michael to factors. I can do these one by one with a mutate for each one of them, but we can also do an across statement like we learned in the code along, I think, last time, where we can say that so I don't want to convert all of the doubles, so I'm going to actually say, so maybe we can say from Halloween to Michael. So the variables from Halloween to Michael, we want them to be as factor. See if that works. In fact, it did. So now from Halloween through Michael, I have them converted to factors. So Halloween, Valentine, Christmas, and Michael have been converted. And the other doubles like IMDB rating and total votes are totally intact. So that's all looking good. The last thing I want to do is bring in the data frame I had that had the office lines in it, right? So let's do a left join to what we have here with the office lines that had information on the proportion of times these characters spoke. And let's do it by episode name again. Sometimes I provide these by arguments, maybe even when I don't entirely need to, but I just want to make sure that I'm combining or joining things by the right variable. Okay, the code ran. That's like a good thing. That necessarily doesn't mean it's perfect, but at least it's a good thing that we didn't get an error. So I usually like doing this view again so that I can see that, okay, all of these things have indeed been appended to my data frame. So I think things are looking good. And then what I'm going to do is I am actually going to save this as Office DF. That's going to be a... Nope. That gave me an error. I tried to save it as Office DF with an assignment operator, and then I can see here in my environment that that's like a null, and then something weird happened. It's because I still have this view at the end, so I don't want to save this pop-up window, right? I just want to save the data frame. So now I have Office DF as a data frame of 186 rows that has all the information that I want for bringing things together. Now, one of the things that happened is that when I joined these data set, I duplicated some of the information, like season X, episode X, and then over here we have season Y, episode Y, meaning that they're coming from the first and the second. And I think that's happening because when I joined these data by episode name, there were actually multiple variables that were that were the same between the two, but I didn't list all of them. So let's go ahead and list all of them. So that will be season, episode, and episode name. Let's see if that solves things. Okay, the X's are gone now. I have season and episode, and then that information is not duplicated later. So earlier we said only match by one, and then R didn't even get a chance to check if there were matches in the other columns. But because the variable names were the same, it just added the .x and .y at the end of these. Now we're saying check for mergeability for all of these columns, and we already know going in that these columns are actually similar to each other. So we can see that we have basically created a data frame that we can do our modeling with. So what we're going to do is in the next video, we're going to continue with this application exercise and actually split our data into testing and training and start building some models.